Hello everyone, this is the solution video for homework 3. Now, there were actually 3 questions, and the first question was to implement a calculator that takes a string, and the string consists of only numbers, digits, and plus and minus signs because they are the only defined operators here. We don't have brackets or multiplication or division whatsoever. So this is kind of a shrinked version. But the cool thing about this calculator is that it takes in the whole string at once and then it evaluates the value of that. So let's actually dive into this. We had actually a template here. So I opened up the template here. I guess I forgot to add the compile.bat file here. Let me quickly generate it, echo off, and then gcc main.c and student.c should make up a file called main. So if I compile, oh, I called it in, okay. Let me just fix that. If we compiled, then we have a main file. If we call the main file, it expects us to put in some expression, but of course it doesn't return the right result because, well, we don't even return anything here. So we are going to implement it here. Let's assume that we return 0 for now. It doesn't really matter. It doesn't matter what I type in, it returns 0. So all the magic should happen here. Now, so before we do anything, we have to actually add a small function, maybe a method that kind of converts the string data into numerical data. So at some point I will need something that will convert that for me. So actually, let's dive into here. Now, in the main file, we don't need this anymore. So this is kind of the main file that we had. It takes in a character pointer and it returns int. And here you can see we have an input of 255 length and we are scanfing it. And then we call our calculator here, the char pointer input here. And well, then we kind of calculate that. Well, I guess we also don't really have to do that. Let me compile. Yep, it just works as it should be, so it doesn't really matter. I can clean that up here. So once we've done that, we will get the result here and display it on the screen with using printf here. So now, since we have an input of 255, I'm going to define a vector of operands. And I can just assume that we will have 128 operands. You can also, if you want to be safe, you can just use 255, or I am going to use 128. I also need a count for this, see operands. So I'm also going to count it. So this is kind of a stack memory that I'm trying to implement here. Then we will have, so these are basically the numbers. Then I also need the operations, plus or minus basically. So if we have 128 operations and 128 operands, that should be enough for a 255 length. So we will also have cops here, which is also going to count. And then basically what I'm going to do is I'm going to define a character C. I'm going to cycle through each character of the string one by one. And then I need to use a for loop here. So int I starts from 0 up to 255, because that was the length that we've decided on. And there we go. Now what I'm going to do is I'm going to extract the character, the ith character of input. Why does it? Oh, it's called string. So let me call it string. So I have this string here. I'm going to get the ith character of it. Now at this point, I'm interested in the following. Is this a number? Is this a digit? Or is it something else? So in order to do that, what I'm going to do is, as you might expect it, I'm going to open it up in a second. There we go. I'm going to use the ASCII table here. I can freely use that. If we look at 48, the decimal 48, we can see it is 0. And if we look at 57, it is 9. So 48 and 57 are crucial here. So if C is greater than or equal to 48, whereas being also less than or equal to 57, then I can see that this is basically going to be a digit here. So this is a digit. So at this point, I'm going to I somehow need to track the beginning here. So I need a mechanism where I kind of detect the first entrance into this. And then I need a certain length. And then I'm going to take that length and convert that into a number. So by this, I mean the following. If I, for example, have a string that looks like 1, 2, 3 plus 1, 2, 3, 4, for example, and I'm starting in this for loop with the first character here, if this is basically between 48 and 57, I see that this is basically a digit. But it could be the case that the next one is a character that represents plus or minus, or it could be the case where the next one is also a digit. So if the next one is also a digit, and the next one is also a digit, I need to track this and count the length of the string that will be basically that I need to take here. And then once I stumble upon a plus or minus sign, I can stop this, take this first part, convert it into an integer, and then store it in the operands here. So that's practically what I need. Therefore, let's actually define an integer index 1 equals -1, there's no index, and then a certain length so that I can track this information here. Now, I'm sorry. So, if we are basically in this, and if I1 is still equal to -1, this is our first entrance here, I'm going to set the starting point to this specific index. And then the length will start with 1, because I have already a character here. Otherwise, if I1 is, for example, equal to I, and I'm still entering this if block here, it means that I have to increase the length by 1. Now, once I'm entering the else statement here, I need to see if, let's say I1, so it could be the case that it is equal to -1, so that shouldn't happen. So we should have already entered this if block here, so I'm kind of checking it again. And the length should also be a positive number. So if this is the case, everything is okay. So I should now push this number to operands, the operands. And at this point, I need the number here. Let's say 123 in this case. So this is basically the first numerical data. I'm storing them in the operands. This is basically keeping track of how many operands there are. Since I'm going to push a new one, I'm going to increase this. Once I've done that, I'm going to reset everything. Len is going to be equal to 0 because I've already pushed in one value here. Now, at this specific moment also, there's something that is quite important here. It is the following. Since I didn't enter or I didn't stumble upon a digit, I actually have the operation here, probably. So I'm not done. I just decided that up to this point, with this length and with this starting index, I have my string data here. I didn't convert it into int now, but I'm going to do that. But let's assume we have 123 plus 1, 2, 3, 4. Then I have completed 1, 2, 3. I've pushed it in. Now I'm going to decide on the operation here. So, so there could be two possibilities. It could be a plus sign, or it could be a minus sign. If this is the case, I'm going to just store it in the operations, and then I'm going to increase the amount of operations. And otherwise, if I stumble upon something else, I'm going to break the loop. And probably what I'm expecting here is I am expecting a null termination here, probably, because then I am at the end of the string, and that's going to be it. Of course, for the first question of this homework, I'm assuming that the string is an okay string. It doesn't contain any other character. It doesn't contain nonsense. So it is a nice formatted string. So therefore, I'm not going to error check everything else. I'm going to just give it a nice string, look at the result. If it's working, then you're good to go. Now, because that would overcomplicate this homework, and I didn't want to make the homework even harder. So yeah. Now, the only thing that is missing now is the conversion of the number. So I am going to implement another function here. So let me first of all compile this. So it compiles. And let me actually display some data before I do anything. So count of operands, %d, count of operations, %d, and a new line. So it would be C operands and C ops. So let's get in 3 plus 3 plus 3. So if I enter this, I can see there are 3 operands, so there are 3 numbers, and 2 operations. So I kind of pushed them into the corresponding vectors. And once I am going to fix this here, or convert the actual number into numerical data and then push it, then I'm going to be able to calculate the result. So now, as I've talked about this, I need a function for this, and I'm going to add a function. It is going to be text to int, and I will have input plus I1. That would be the address of our string plus I1. So this is basically the starting address of our string, and then we will also have a certain length to it. Now, let's implement this. So it's going to be a integer text to int, and it takes a char pointer, I'd say string, and then int length. You don't really have to have a function for this. You could do it here in one line, but for now I'm going to write a function. Maybe we can decide upon something else. So the result will be stored in int num, and I'm going to again use a for loop here, and the for loop will be starting from I, 0, I less than the length, I plus plus. So, now we have kind of the length of our of our string that will basically determine the 10th power here. So we will at some point need a pole here that will be 10 to the power of r. And this r is going to be an integer. And I need to calculate this r here. So for example, if we have 1, 2, 3 here, if the length is 3 and I is equal to 0, it seems like it would be 3 minus I minus 1. Because I need 10 to the power of 2, 10 to the power of 1, and 10 to the power of 0. So, now, therefore, the length of this minus I and minus 1 should be basically corresponding to 3 minus 0 minus 1, so 2, so 10 to the power of 2. So if I increases, you'll see that if I increases, we will get basically lower values for r, so the base is going down. And when we have len minus 1, which is the last value here, we will get r equals 0. So this is basically the power. Now, we also need basically the digit here, int digits here. And there's actually a cool way of doing it. I can basically extract 48 from 48, so the digits as the numerical value will be stri minus 48, because the character itself starts at 48 if it's going to be 0, and it will be 57 if it's going to be 9. And if I extract or subtract the value 48, I can convert the character representation like 0 or 1 into 0 or 1, because there's an offset. If I take out the offset, it will show me what the actual value is. You can use an if block, if else block, whatever, but I guess this works like a charm, so yeah. Now the only thing that is left is basically to calculate the number here. So num plus equals, or num equals num plus the digit times 10 to the power of r. So that should be it, I guess, here. Once we're done with that, we will return basically the number here. So yeah. Let's test it out, actually. Let's yeah, actually I can use this part here. Once I'm done, instead of showing the stuff here, what I can do is I can just use a for loop for and display them using printf maybe. So for int I equals 0, I less than C operands, I plus plus, printf %d operands, C operands, then closing bracket, I guess. Let's compile it. Let's run it. 3 plus 3 plus 3. It didn't work. Nice. Now, what could be the issue here? We have to debug it a little bit, I guess. Yeah, why did we mess this up? So str plus I1 when we have the length. It should be okay up to this point. In the for loop, we get the character. We check if it's a digit. If I is equal to -1, then we set the index, then the length. Then we have len plus plus. If this is not that, and if len is a positive value, we are basically, did we return the number? We return the number, starts with 0, we get the digit, so we shouldn't be in trouble here. So digit times 10 to the power of r, where r is this. Interesting. Why did we mess up? Interesting. I'm going to test this out because I'm not sure what the problem is. So let's call that on char test 3 equals 1, 2, 3. So yeah, then we send it tests, and the length is basically 3, and it should printf %d. It should return an integer. Let's see. Interesting. Now we have 122. So why is that? Why do we have 122? Instead of 123. Let us add this and also test maybe. guess it's not null terminated. Is that the issue here? Yeah, it was not null terminated, now it is, so that's nice, but we have 122. Why do we have 122? So let's see. We calculate R. It's len minus 1 minus I, or I minus 1. And then we have the string representation minus 48. Let's have a float number. What can we call it? Well, let's call it temp, maybe. And let's break this into digit times that and add the temp value here. The reason why this could be an issue is that the num variable is an integer and the temp variable is a float. I'm not sure, but I kind of want to try this out. Yeah, it seems like I was correct. So it messes up the data type when we have digits, which is an integer, but po, it is a floating number, so it's not calculating it correct if we directly drop down to integer, because num is also an integer. So po was kind of integer truncated at this point, so we needed an extra step for that. So let's actually see if it works now. We still have some issues here. Now, why do we have them? This is basically an integer. Now, I have seen that this is correctly interpreting it, so it shouldn't be an issue. So why do we have still trouble? If I miss that, we do this one here. Other than that, we have diff operands. So why did we still mess up? Interesting. Let us printf here. To see what's going on here. So num, let's take this, store it here, and num, and let's see. Interesting. Now it seems to be working. 323, 345. I'm not quite sure why this should be an issue. Interesting. What happens if I open this up? Yeah, this one works, but then here, if we use, do we access something that we shouldn't access here? Operands, maybe it's out of scope or something. Let's see, we have the operands here, and then C operands. We're using them, we're assigning it here. I am definitely missing something here. I'm quite sure of that. Because it doesn't make sense. If I can use it here, I can use it here. So once I assign it, let's see what's then going on. Let's see. Interesting. I can still see these, but when I access them, I see some weird numbers here. Because I'm not using I. Okay. Sorry for that. I've seen it now. I'm accessing something that I shouldn't access. Okay. I forgot it somehow. Yeah. Let's fix this code real quick. So we have basically what we want. It took a little while, but yeah. So we can see it's 3, 4, 5, and we have our operations and operands. Now, it's actually easy from this point on because we will have basically a result that would be basically the first operand here. And then I would rather start at 1. And I am going to go through the operands. Now let's have an index variable here that is going to be used for the following here. So we will have an if statement here because the arithmetic is coming basically here. So if this is basically a plus sign, or else if it is going to be a minus sign. There we go. Of course, this should be like that. Now, if that's the case, then the results will be incremented by the operands I. There we go. Otherwise, we will decrement it by operands I. Once we've done that, we got rid of an operation, so increment the operation index here. And well, at this point, we should be almost good to go. So let's return the result. Let's see what's going on here. So 3 plus 3 plus 3. You can see it's 9. So 3 plus 3 minus 3 should give us 3. And we can go on like that. So this should be 55 because 10 times 11 divided by 2 gives us 55. And we are done with the first question. So if you don't want to have a function, you can take the internals of this, just add another piece of code here. But I did separate it for this question. So yeah, that's it basically. Now, we had another question where we were interested in calculating the integral that was given here. And there were two different integration methods mentioned. One of them is the Simpson's rule. The other one is basically a numeric integral. So let's dive into those. Now we have here the Simpson's rule. And since we have float a and b A is the lower bound, B is the upper bound. This one is quite easy actually, because we're looking at a specific formula here. The step size is basically, for example, B minus A. And due to the rule, what we can do is we can just use the following formula here. I guess you should have picked up on this one here, because it is very, very easy. Let's calculate basically the integral. It uses the lower bound A, the upper bound B, and then somewhere in the middle, and we're just taking the weighted average basically. So that's what it is here. So let's take sine of A. This is basically in parentheses here, plus 4 times sine A divided by 2 plus B divided by 2, or A plus B divided by 2, whichever you want, plus sine of B. So this is going to be returned here. Basically, did we mess up anything? I doubt that. You can see that the coefficient of this is 1, this one is 4, and then there's 1. It gives the sum 6, and you're dividing by 6, so there's a normalization going on. It is weighted average. So, yeah, I guess this should be it for the Simpson's rule. Now let's get rid of this whole thing here. So this was basically the test code for question 1. Let's actually look for question 2. Let's printf the result here, and we're going to use integrate the Simpson's rule. The starting point is 0, stopping point is pi divided by 2, and we should be good to go. So let's compile. Let's run main. It is 1.001477. It is basically this from 0 to pi divided by 2, the integral. So it is something that is pretty much known here. The value is pretty much known. So then we have the numeric version here. Here for the numeric version, what we are going to do is basically we will use a for loop. And for this for loop, so let's write a basic for loop first. So why we need a for loop is basically because of the rectangularization of the signal. So let's assume we have a certain signal. In this case, we have a sine wave. Now, what we are going to do is we are going to split it in vertical lines, and then we will get some rectangular areas. What we can do is we can use the width of it, which is going to be, because the x-axis is basically time, which is going to be the time step times the value of that point, so that we get basically the area, approximate area of that rectangle. And if we do this and add them together throughout the interval, we can basically just use this rectangularization method to calculate the area, or this integral. So for this we need a step dx in the x-axis. So I'm going to use the b minus a, the interval here, and let's divide it into 99 pieces. The reason behind that is going to be the following. I'm going to use 100 as a number, so 100 iterations, but there are already 100 points here, I guess. And so the first one will be basically starting at A, and we will add 99 pieces to get to B, basically. So yeah, let's define a sum, and this sum should be equal to 0. let's create a variable x, because x will give us basically the coordinate that we will use. So x is going to be the following. So I'm kind of using linear spaced vector. If you know MATLAB or any other thing, there is something called linspace, and you then use linspace a and b and some number of points. I'm basically using this strategy here. Since a and b are included, I need to use b minus a divided by 99. So I can actually printf the value of this. So step size dx is %f, and then dx, in order to see what's really going on behind the scenes here. And now, what is x going to be? Since I'm using linspace, but I don't have that function and I don't want to implement it here, I'm using the starting point, then dx times I. So that's basically it. The starting point is a. I'm going to add b minus a divided by 99 times I. If I is 0, I will add nothing. If I is 1, I'm going to add one sample, and I'm going to do this throughout the loop here. So I'm adding the area, which is basically sine of x times dx to the sum. And once I'm done, I have basically the integral here. So it's basically a for loop, but it uses a step size here, dx. So we start at a plus dx times 2 times 3 up to b. And at each point we have a value for our function times the step. So we kind of approximate it with a constant, so it's kind of a zero order whole thing going on here. And that's it basically. So let's actually go to main C here. Let's also call the other integrate method, which is integrate numeric. We give it the same stuff here, and you can see the step size here is 0.015859. So you can adjust this, change this as you wish. Now, am I going to be able to, for example, what happens if I divide it by 101? I'm not sure. Let's see. Yeah, it changes kind of the result. But of course I need to change this too, I guess. So we could actually do the following. We could define something like in samples, and then call it like 10. Should I divide it into samples plus 1? And then we would use samples here, I guess. So let me compile, run. You can see the step size. If we change it, the integral gets off. But if I increase it, like if I have 1000, it approximates it quite good with this step size here. But as you can see, actually 100 is more than enough. So there we go. Actually, I'm not sure. Maybe it should be -1. Maybe I'm missing the point here. So if I want to see what it is, basically, we would multiply this with samples -1. Yeah. So you can see that this formula here, you can interpret it like the following. We have dx, which is by definition this one here. And I, the maximum value of I, it should be less than samples, is going to be samples -1. So you can see that they will cancel each other out. You will end up in a plus b minus a, so a cancels each other out, and you will end up in b. So this is basically the reason why I'm subtracting 1 from the sample instead of adding it. So let me just compile it again, run it again. You can see 1, 0 is kind of the result here, and the step size is this. So if I increase it, it will become even better. You can see 0.999989, which is practically 1. So yeah, let's get rid of this and of this. So you can decide upon the, because it is going to be a for loop, it takes some time. If you increase the accuracy, it will take more time. If you lower the sample size, it will basically become more efficient. But you can see that the Simpsons rule is a special rule that can be used, and it is way better in terms of approximation than this one, because it uses 3 distinct points: the middle point, the starting point, and the stopping point, and it's way more efficient than that. So let's compile and run it again to see it works and it is acceptable. So this is basically question 2. Hope that this was an easy one, because it was supposed to be easy. So now we will have actually the grading example here. Now the aim here was to read input.txt, write a certain output.txt, where the input.txt file looked like this. So we have the midterm and final exam grades, and the it is comma separated. So 40% of the midterm and 60% of the final grade gives us the average grade. So it's a weighted average. The grade is converted into their letter representation using this table here. And this is basically the output that we should create, where we also have the average of the midterm exams, average of the final exams, and average of the averages, basically. So let's dive into this one. Here we have the grade function. Everything will be happening in here. So since we have a file, let's read that file. And let's open up the file. Input.txt. And reading mode. If the pointer is null, if it's empty, basically, printf I'm sorry, error, the file does not exist, etc., etc. Exit 1, not really that important. But yeah, actually exit 1 is not a good strategy at this point. It should be throwing an error, and we should catch that and check for it, or we should do something else. But yeah, not really that important, because we're not really interested in this. So we have a bunch of students, but we can use some static memory. We can go ahead and define this as 256. If you want to be even more general, what you can do is you can have a define statement here, like capacity, something like that. It's commonly used. 256, and then you can just use capacity like this. But I'm going to use 256. It's not really that important for this case. I'm going to test it with a small set of students, but ideally maybe thousands of students can be in a classroom, but then the classroom is too crowded. So there's an ideal number, but I'm not going to argue with that. So we have the midterm, we will have the final exam. We also need to have some average. And I am going to use actually, so what you can do for the letters, if it's DC or DD or AA, what you can do is you can maybe use 256 times 2 and then a complex structure, but I like to keep it simple, so I'm going to go with G1, the first letter of the grade, 256, and also the second letter of the grade, 256, and that's going to be it. So I'm not going to bother with that. Now we need also the float midterm averages. We will have the final average, and we will also have the grade average, so the average of the grades. So Well, we will have an index because we are using some arrays here, and I'm going to use a while loop because I don't know how many lines there are. So based on the assumption that we will have comma separated integer values, it could be float. I didn't force this to be a float number. If you have a float number, it should be okay. I'm not sure because in Excel, as far as I know, most of the time the separation or the datetime format or the currency formats, they mess up stuff, so I wanted to keep it simple. Therefore, I'm going to go with basically integers. But of course, it doesn't have to be integers. But then again, most of the time the grades are integers. So yeah. Well, let's have basically scanf, which is scanf basically, but for files. And then we have fptr, which is the pointer. And then as usual, we just use comma separated %d. And for the first one, we are going to save it into the midterm here, and then into the final I. And yeah, that should be it. And while this is positive, as far as I remember, fscanf returns bytes, readed bytes or elements, something like that. So if it's not zero, if it's zero, it didn't read anything, so this while loop will stop basically. Um, what I like about C is that it has a convention here. We have fprintf, for example, which is the printf for files, whereas you still have printf, which is that. We have scanf, but then fscanf, because why not? So I like this convention, so you can think about this as a scanf. The only thing that is changing here is the stream here. If you don't use f and don't provide any pointer here, it assumes that it is using stdin. As far as I know, you can also do something like stdin here, fscanf, and it will become scanf on its own. So now I assume that, since I'm reading line by line, I assume that I have now the values available in mid-I and final I. So the average then will become basically the ith average, because this is the ith student here, is going to be 0.4f times the mid term plus 0.6f times the final grade here, I. Now, since I'm at it, what I can do is I can just use mid average here plus equals mid I. So I'm kind of summing all the midterm and final values. Even though the name of the variable has average in it, it's not an average at this point. It's just a summation. But once I know how many students there are in this class, I can just divide it and it will become an average. So grade average going to be average here. So now the tricky part comes, but it's not really that tricky. It will be a bit of a pain. So if the average point of this student is greater than 0, and if the average of this student is less than or equal to 29, then the following will happen. The G1, the grade letter, will be F, and the second letter will become basically also F. So we will have multiple of them. I don't know how many. Let's copy and paste them a bunch of times. 1, 2, 3, 4, 5, 6, 7. Let's stop at 7. So this one, this one, this one. So these are all else ifs. Now, if it's greater than 30, so we can use this table. I'm actually using this table here. So if it's between 30 and 41, it will become dd. If it's greater than 42, greater than or equal to 42, and 53, it is going to be dc. If it's greater than 54, greater than or equal to 54, up to 64, it is going to be 54 cc. If it's going to be greater than 65 and less than 76, we will get a grade of CB, I guess. If it's greater than 77 and less than 87, it should be BB. If it's greater than 88 and less than 93, then it's going to be BA. If it's greater than 94, less than or equal to 100, it should be A. Else if. So this is going to be one student, so then I'm going to increase that. And once we're done with this for loop, I can assume that we are actually done with all the students here. So once we are out of this while loop here, I'm going to close the file here, fptr, and then I'm also decrease 1 here because I'm incrementing at the end for the next student, but if there's no next student, I should just subtract 1 in this case. So I know how many students there are. I can just calculate the mid average. So that would be, I have the sum here. I have to divide it by I, and that's the only thing I have to do. Then we will have basically the final average. I'm going to divide it into I, and then grade average like this. So we're actually ready. The only thing that we should do now is to open up a new file and call it output.txt. Now we're in writing mode, and I can now use a for loop. I know how many students there are. For int k equals 0, k less than or equal to I, k plus plus. Now we're going to fprintf everything here, and the file pointer here, and then let's have percentage 4.2f, comma 4.2f. Let's hit a separator here, and then 4.2f, another separator. Now the letters, and then new line. So basically, I'm going to convert it into float, and it would be the mid k here because I have stored them as integers, now I'm just producing them as floats because I've used floats. We don't really have to do this, but yeah. So just gonna do it for now. Because everything is in float, I have converted into floats. So the average here is going to be printed out, and then the first letter of the grade, and then the second letter of the grade, and this should basically be it now. 1, 2, 3, 1, 2, 3. Yeah, seems all right. Once we're done with that, let's add a separator here to indicate that something's finished here. And I'm kind of going to copy this here. We will still have these values, but now I don't really need this one here. And I'm going to just show the mid average and then the final average. And then basically the grade average here. So let's then close the file pointer here, and let's see if we can compile it. What is the issue here? stdlib maybe, if that's missing here. Oh, I forgot to provide the file pointer here. Let's solve that. Yeah, seems all right. Now in main, I'm going to comment out this previous one here. So let's have Q3, and let's call grade, and that's basically it. It doesn't take any arguments, anything. So now we have this input file here. Now we have this output file here. Seems like we messed up stuff here. Let me see. Grade 2I is A, B, C, and C, D, and F. And here we have K, percentage C, percentage C. Doesn't seem to be an issue here. So we did it almost, but there are the grades, no problem. But the last letter here. So let's see the definition of that. We have characters G1 and G2. Doesn't seem to be an issue. Interesting. Again, I'm not seeing the issue here. I don't know why. Interesting. So this is the first one here. So this is mid K. This is final K. This is average I. And then we have G1 and G2. So what seems to be the issue here? Interesting. Let's run it again. But yeah, it doesn't change, of course. Did I miss something? So I don't get it. I have actually characters. So these are integers. Oh, maybe this is causing an issue. I guess this should be floats here. There we go. Now that was the issue here. Yeah, well, actually, about the this being float, I might just use D and then D, 3D, I guess, and drop maybe the float parts here. Just a thing of aesthetics, but it's not really that important. Yeah, at least it seems like a little bit better, but it doesn't matter. We can see that the program works now. So this was basically, I guess, these two questions here, question 3 and 2, were fairly easy. The calculator one is also a simplified version, but yeah, it has this operand stuff, operation stuff. You have to come up with a conversion between the text to integer here, and then, well, do the job. Hope that this was helpful for you. See you in the next videos.